Everyone, we're going to be talking about a moving ladder. A ladder is 25 feet long. Here it's leaning against the wall. The base of the ladder is being pulled away from the wall at a rate of 2 feet per second. Now, it says how fast is the top of the ladder, this should be of the ladder, moving down the wall when its base, so 7 is 7 feet, 15 feet, and 24 feet from the wall. So we have three parts here on A. 7 feet, 15, and 24 feet from the wall. And then we have to also consider the triangle formed, which we already did here. Find the rate at which the area of the triangle is changing when the base of the ladder is 7. So that would be this first one we'll have done. And then we have to find the rate at which the angle between the ladder. So we're considering the triangle formed and the angle between the ladder and the wall. So right in here would be the angle. Okay? And we're going to do these three things. So the first thing we're going to do is this, which has three parts. Okay? The first thing we're going to use Pythagorean theorem, and that is going to be our a squared plus y squared equals c squared. In this case, it's x squared plus y squared equals 25 squared. Alright, and then we're going to take the derivative of x, so it's 2x, and that's the derivative of x with respect to time, plus 2y times the derivative of y with respect to time equals 0. And basically, we're going to get, if I solve for the derivative of y, I'm going to get derivative of y with respect to t equals, I'm going to subtract him, so that's going to be minus 2x times the derivative of x with respect to time, divided by, then I'm going to divide by 2y. So 2's cancel. So basically, derivative of y, this is y, not t, derivative of y with respect to time equals negative xy with respect to x, or derivative of x with respect to time. Or you could say derivative of x with respect to time, and you just flip this as negative y over x with derivative of y with respect to time. So those are your two formulas, and what we want to do is find, we know that the derivative of x with respect to time, the part that's changing on the x, equals 2. It was 2 feet per second. So basically I'm just going to plug that in my equation. I'm going to get when x is 7, that's the first thing we want to do, we get y equals the square root, I'm plugging it in here, it's going to be the square root of 576, which equals 24. Alright, so that's going to give you, and we already know that, so what we're going to do is just plug it in. We've got derivative of y with respect to t equals x is 7, so we have negative 2 times 7 over my y. My y was 24, and that's going to equal negative 7 over 12 feet per second. Okay, so when x is, this is when x was 7. So when x is 15, we're going to get y equals, and that's plugging it back into the original formula, square root of 400, which equals 20. So I'm just using the Pythagorean theorem there. Then we're going to do derivative of y with respect to t. and that's going to give you negative 2 times 15 over 20, which equals negative 3/2 feet per second. That should be per second. Alright, the same thing, we're using Pythagorean theorem for when x is 24. And we already know that when when y was 24, our x was 7. So this is just mean y is 7. That just means 7 squared plus 24 squared equals 25 squared. Remember, these are your Pythagorean triples. So really, you should just kind of know those by now anyway. So now we're going to use our formula. Derivative of y with respect to t equals negative 2 times 24 over 7, which equals negative 48 over 7 feet per second. Alright, and the next part we have to do is part B, and that's the part where you have to find the rate at which the area of the triangle is changing. So basically, you're going to take the area of the triangle is 1/2 base times height, which in our case is going to be x times y. So the derivative of the area with respect to time equals 1/2, and then you're just going to take x times the derivative of y with respect to t. This is the chain rule, not the chain rule, the product rule, plus y times the derivative of x with respect to t. Alright. From part A, we know that when x is 7, y is 24, and we have the derivative of x with respect to t equals 2, and the derivative of y with respect to t equals negative 7 over 12. So all I'm going to do is use from my part A information and plug these 4 numbers in. So the derivative of our area, the rate of change of our area with respect to time, is 1/2. Our x is 7. Our derivative of y with respect to t is negative 7 over 12, plus our y, which is 24, times 2, which is the change in x with respect to time. When you clean all that up, you get 527 over 24 square feet per second, which is approximately 2196 square feet per second. And the last one we have to do is the angle. So the angle, we're going to use tan, because we know tan of theta equals y over x. And we already have our y and our x. The first thing we have to do is take the derivative of tangent, and derivative of tangent, our angle, is secant squared, times the derivative of our angle with respect to time. This is a y. Alright, so this is going to equal 1 over y times the derivative of x with respect to time minus x over y squared times derivative of y with respect to time. Alright, now, so therefore we have derivative of our angle. This just means I'm writing, this is 1 over cosine squared. So derivative of our angle with respect to time equals cosine squared times 1 over y times dx over dt minus x over y squared times dy over dt. Alright, now we're using x equals 7 and y equals 24 And derivative of x with respect to t equals 2, and derivative of y with respect to t equals negative 7 over 12. And so it's going to be, you plug all this in, and we know that cosine of theta equals 24 over 25. So, because cosine of theta is equal to 1 over blah, blah, blah. Anyway, so there's that. Now we're going to plug everything in, and we're going to get derivative of our angle with respect to t equals 24 over 25 squared. Okay. Remember, this is our angle. This is 25, and this is our adjacent. So cosine of angle is adjacent over hypotenuse. So that's where we're getting that. And then we're going to fill everything else in. We get 1 over 24 times 2 minus 7 over 24 squared times negative 7 over 12. And when you multiply all this through, you're going to get 1 over 12 radian per second. And that's all. Thank you. Have a nice day. Bye-bye.